We're given another sequence and we're asked to determine if it's arithmetic, geometric, or neither. When we look at our general term for the sequence, we have negative 1/2 times 4 to the n. Notice that our index here, n, which is going to be in our exponent, is not going to allow us to get an arithmetic sequence because it's not being multiplied or added. It's part of the power. We suspect it could be geometric because this kind of has a form of what a geometric sequence might look like. To check that, we're going to look at the ratio of consecutive terms. So we want to find the ratio a sub n divided by a sub n minus 1. So the nth term divided by the n minus first term. This is a sub n that we're given here, so we'll have negative 1/2 times 4 to the nth power. That will be divided by negative 1/2 times 4 to the n minus 1 power. We can rewrite that. So it will be negative 1/2 times 4 to the n minus 1 times 4. We're just rewriting 4 to the n over negative 1/2 times 4 to the n minus 1 power. We notice that this negative 1/2, 4 to the n minus 1, that cancels, and we get that this ratio is equal to 4. We've done this in general terms, so what we've shown is that the ratio of consecutive terms in our sequence is a constant. That constant is 4. That's our common ratio, r. The first term, a sub 1, will be negative 1/2 times 4 to the first power, so we'll end up with negative 2. We were asked in the problem to see if it's geometric, and if it is, to find the common ratio, which we did, r is 4, and then also the sum of the first n terms. So we'd like to find s sub n for this geometric sequence. For a geometric sequence, the sum of the first n terms is given by the first term times 1 minus the common ratio raised to the nth power divided by 1 minus that common ratio. We found the first term and we found r, so we'll have negative 2 times 1 minus 4 to the n divided by 1 minus 4. Just clean that up a little bit. We'll end up with 2/3 times 1 minus 4 to the nth power. And this represents the sum of the first n terms of that geometric sequence.